Let me tell you the secret to spring break. Would you like to know the secret?
Yeah.
It's all fun and games until someone loses an eye or gets pregnant. There you go. And I want to remind you what's at stake here. We've got exam 2 coming up. The golden thinker is still up for grabs. So motivation, right? Okay. Let's talk about what you guys want to see. There are 25 questions on that exam practice. Start yelling out the numbers of the ones you want to see. Okay. Let's get going here. The first one is number 4. The geometric average of -9%, 20, and 23% is. Remember, with geometric average, first of all, the returns have to be in decimal form. That's number 1. Number 2, we have to add 1 to each return. And then we're going to multiply all that stuff together. And then we're going to take it to the 1 over n power. What's n here? 3. Yeah, 3. So it's 3 points. So let's get started here. By the way, is there an easy way to do this on the calculator? No. 1 minus 0.09 equals 0.91 times 1.2 times 1.23 equal. Have I blown anyone's mind yet? Okay, now we're going to have to raise this to the 1/3 power. What button do I hit next?
Y.
Yeah, y over x, open parentheses, 1 divide by 3, close parentheses, equals. What's the next step?
-1.
Yeah, remember we added 1 to everything, so we have to subtract 1 here, equals, boop, and then I multiply by 100 to get the percentage, and that gives me 10.3%. Questions? All right. Number 5. Sexy Socks. Stock was $26 per share at the end of last year. Since then, it paid a 70% per share dividend. The stock price is currently $24. If you owned 300 shares of Sexy Socks, what's your percent return? Do we even need to know how many shares of Sexy Socks we own? Nope. Okay, now the thing that really messes people up is they are not used to problems where the price of the stock goes down during the year. So the capital gain on this is actually how much? -2, right? We've got -$2, but then we get 70 cents back. So that gives us what? -$1.30. And then, what do I have to divide that -1.3 by?
26.
Yeah, it's the original price. And that gives us -5%. Questions? Okay, now we're on to number 6. The past 5 monthly returns for Kentucky Jelly are 3.25%, 7.13%, -3.05%, 4.25%, and 6.75%. What's the standard deviation? How should I go about doing this? Yeah, use the calculator. We're going to say second data. I'm going to do second clear work. Okay, so I'm going to put in 3.25 right there. Enter, arrow down, and I'm going to put 7.13 there. Enter, arrow down, 3.05 negative, enter, arrow down. The fourth one, 4.25, enter, arrow down. And the last one, 6.75, enter. Now, just to make sure that I've got these numbers right, I'm going to roll back up through them, make sure they all look fine. Most common mistake, people forget to put the negatives in. Okay, now, how would I go about finding the standard deviation? Second. And the number 8, which says stat above it. Now we're going to arrow down. N is 5, is that correct?
Yes.
Yeah, always check that. Arrow down, the mean, they didn't ask for it, but there it is. In our sample standard deviation, is 4.0966, so the answer would be 4.10. Now, what if instead I had asked you for the variance? Yeah, we just square this number. Boom, and there you go, that would be it. Notice when I do that, the equal sign goes away, the calculator says, hey, wait, that's not what I calculated. How do I get the old one back? Arrow up, arrow down, and there it is. By the way, do we do anything with this number? Absolutely not. Leave it alone. Questions? Okay. Number 7. A security with normally distributed returns has an annual expected return of 16% and a standard deviation of 24%. The probability of getting a return between minus 8% and 40% in any 1 year is. Okay, so this is one of those normal distribution things. By the way, do you have the normal distribution on your note sheet? If you don't, you need to. Okay, so we have the mean is 16% and the standard deviation is 24. So we're actually figuring out how far these two numbers are away from the mean. And if I had to guess, I'll bet they're the same distance. So it says probability of getting a return between negative 8%. So we're going to say negative 8 minus the mean. How much is the mean? Expected return? 16. Divide by, what's the standard deviation? 24. So this is equal to minus 1. And so here we have, what, 40? 40 minus 16 divided by 24 equal plus 1. What percentage of all observations are between minus 1 and plus 1 standard deviation? 68.20 something percent, right? And so it would be the first one. Questions? Okay. Moving on to number 8. Oh, this one's tricky. So, if the daily returns on the stock market are normally distributed with a mean of 0.05% and a standard deviation of 1%, the probability that the stock market would have a return of negative 23% or worse on any particular day is approximately. Oh, this is hairy. Here we go. It's hairy because the numbers are not what you'd expect. Okay, so we know it's x minus x bar divided by s sub x. And they're saying the x here is minus 23. And we're going to subtract the subtract the expected return, which is the mean, 0.05, divide by the standard deviation is 1. So what do we got here? We've got minus 23.05. Okay, now if I'm looking at the normal distribution and I'm looking at a single tail and I'm looking at minus 1 standard deviation, how much is it left in that other tail? Well, it's 100 minus 68 divided by 2 is 16. And if I've got minus 2 standard deviation, how much is left in the tail? It's 100 minus 95 divided by 2 is 2.5%. So the tails are getting smaller, smaller, smaller. If I do the minus 3 standard deviations, we know that it's actually 99.74%. So each one of those tails only has 0.13% in it. Now we're getting tiny, tiny, tiny. So if you've got 0.13% at minus 3 standard deviations, what have you got at minus 23 standard deviations?
0.
Yeah, damn near nothing, right? Does that make sense? What makes that problem difficult is it throws a number at you that you'd never even contemplated before, minus 23 standard deviations. Okay. And we don't have to do number 9, all right. I'm amazed because I expected you folks would ask that question. Whatever floats your boat. Here we go. Suppose the beta of Andes is 1.7, the risk-free rate is 3.5%, and the market risk premium is 10%. Calculate the expected rate for Andes. Anytime you see one of these problems, the first thing you ask yourself is, have they given me the market risk premium or have they given me the expected return on the market? If they give me the expected return on the market, I have to subtract the risk-free rate to get to the market risk premium. If they have already subtracted it out and they give me the risk or the market risk premium, I don't have to subtract out that R sub F. So what have they given us here? Yeah, they've given us the market risk premium. All we have to do now is multiply that by beta and add the risk-free rate. So we've got a beta of 1.7 times the market risk premium of 10%. So I'm going to go with 17% there and add 3.5%. What's 17.3.5? 20.5. Any questions? Suppose the beta of ExxonMobil is 0.75, the risk-free rate is 5%, and the expected market rate of return is 15%. Calculate the expected return on ExxonMobil. What did they give us? Expected market return or the risk premium? They gave us the expected market return. So what do we have to do with that number? I got to subtract out that risk-free rate. So 15 minus 5 is how much? 10%. 10% times 0.75 is 7.5%. Then I'm going to add the risk-free rate of 5%, and that should give me 12.5% as my number. Any questions? Number 12. A portfolio is composed of two stocks, A and B. Stock A has a standard deviation of 35%. Stock B has a standard deviation of 15%. The correlation coefficient between the returns on A and B is 0.55. Stock A comprises 40% of the portfolio. Stock B comprises 60% of the portfolio. The standard deviation of the return on this portfolio is. Now, first thing you want to look for when you see a problem like this, did they give me covariance or did they give me correlation? Which one did they give us? Yeah, they gave us correlation. So that first two asset portfolio variance formula that I gave you isn't going to work. We'd have to do some rearrangement. By the way, fortunately, the rearranged version is also on your PowerPoints. So I'm going to write the formula on the board here, but I'm doing this from memory, and I want someone to tell me if I get it wrong. Hopefully some of you have your note sheet with you, right? Okay, here we go. I think the variance of the portfolio is equal to the weight on A squared times the variance on A plus the weight on B squared times the variance on B plus 2XA XB correlation of A with B times the standard deviation of A times the standard deviation of B. Does that look right? Mr. Sabed says yes. Okay, now, here's the part that people miss out on. This whole thing right here, that is the covariance of A with B. We had to do some substituting to get there, right? So what I would encourage you to do is to have both of these equations on there, or you could just write it like this. Now, the next thing is to go through here and fill all this stuff in. What is the weight on A? 0.4. Yeah, 0.4. Now, they also tell you that there is 60% of the portfolio in the other thing. Did they even have to tell you that? No, because we know the weights have to add to what? 1. Right? Have to add to 100% or 1. Okay, so we're going to do 0.4 squared. What's the standard deviation of A? 0.35. Yeah, 0.35. You got to do it as a decimal. 0.35 squared plus weight on B, we said, is 60% squared times, what's the standard deviation of B? 0.15. How much? 0.15? Thank you. Okay, plus 2 times x sub A is 0.4, x sub B is 0.6. Correlation of A with B, what was it? 0.55. Yeah, 0.55 times the standard deviation of A, which was 0.35, times the standard deviation of B, which is 0.15. Okay, here's what I'm going to tell you. When we work through this in the calculator, if you try to do this all at once, you will get the wrong answer. I can guarantee it. So here's the game we want to play. We want to calculate this and put it in location 1. We want to calculate this, we want to put it in location 2. And we want to calculate this, and we're going to put it in location 3, and then we'll just add those all together. Are you ready? Okay, here we go. That first one is oh, by the way, 0.4 times 0.35 squared is the same as 0.4 squared times 0.35 squared. Do you guys know that? Yeah. Okay, so what I'm going to do is I'm going to say 0.4 times 0.35, and then I'm going to square that. 0.4 times 0.35 equals, and then I'm going to square that, and then I'm going to store that in location 1. Now, the next one, I'm going to say 0.6 times 0.15 equals, I'm going to square that, and what am I going to do with it now? Store it in location 2. Now it gets really hairy. 2 times 0.4 times 0.6 times 0.55 times 0.35 times 0.15 equal. Is that the number you're getting? Okay, I'm going to store that in location 3. Now what am I going to do? Recall 1 plus recall 2 plus recall 3. Is that the standard deviation? No, what is it? Variance. How do I get the standard deviation? Square root. And I'm getting 20.39%. Does that make sense? Now, the big trick there, it's like expected market return versus market risk premium. You've got to read. In order to succeed in finance, you've got to read before you do your math. Read for correlation versus covariance there. Okay, the standard deviation for investment A is 10.10. Standard deviation for B is 0.04. The correlation coefficient between the returns on A and B is minus 0.25. The covariance of returns on A and B is, well, remember up here we said the covariance of A with B is equal to the correlation of A with B times standard deviation of A, standard deviation of A times the standard deviation of B. They're asking us for covariance, so all I've got to do is take, this is minus 0.25 times 0.10 times 0.04. Let's put that in the calculator and see what we get. 0.25 negative times 0.04 times 0.1 equals. I'm getting minus 0.001. Is that the right answer?
Yeah.
Cool. And it's ready for the trash can. Okay, number 14. Do you have a question?
Yeah.
Okay.
Your squiggle, next to A,
It says
with the covariance, is that a variance or a standard deviation?
it's a standard deviation, and I can tell you how you know. Because if it had been a variance, what would it look like? There'd be a 2 there,
Okay.
because it's squared, right?
Yeah, I didn't understand your squiggle. So.
I'm sorry.
No, that's okay.
Yeah, my handwriting is for crap.
I just didn't know what it meant. Thank you.
You're welcome. Other questions? Yeah, folks, if you have questions, ask me. Okay, here we go. I'm gonna do some erasing here. Okay, your investment has a 40% chance of earning a 16% rate of return, a 50% chance of earning a 10% rate of return, and a 10% chance of losing 4%. If you add all those percentages up, what do you get? You gotta have 100%, right? Okay, so I'm gonna go through here and we're gonna say 0.4, 0.5, and 0.1. And then they give us the return for each of those scenarios. The first one is 16%. The second one is 10%. And the last one is minus 4%. Keep in mind, losing means minus. Now, we are working toward finding the standard deviation, which means we're going to have to find the individual deviations, which means that we need to find what first? Yeah, the expected return. So, expected return here is going to be equal to 0.4 times 16% plus 0.5 times 10% minus 0.1 times 4%. You see that I just moved the minus sign out? Okay. Now, I can go through here and do this math. I can do this in my head. You guys can use the calculator, whatever suits you. But I think this is 6.4%. I think this is 5%. And I think this is minus 0.4%. And so that makes our expected value 6.4 plus 5 is 11.4 minus 4 is 11. Does that sound right? Okay. Now, the next thing we need to do is figure out the deviation for each one of these. And then we're going to figure out the deviation squared. And then the last thing will be the probability times the deviation squared. Students are tempted to work like this. Boom, boom, boom. What should you do?
Work across.
Yeah, work across. Okay, so we're going to take 16% here. 16 minus 11. I'm going to write these down, although you probably don't need to on the exam. So that's 5. Now, what's the deviation squared? 25. And then I'm going to multiply that by the probability. What's the probability? Yeah, 0.4. And that's going to give me 10. Now, here's what I'm going to do with that number. I'm going to save it in location 1. Store 1. Okay, now we start on the next line. 10 minus 11 equals negative 1. What do I do next? Square it. What happened to the negative? Yeah, negative times negative is positive, right? And then we're going to multiply this by the probability. What's the probability? 0.5 equals. And so I'm going to store that where? 2. See, I'm not even having to write this stuff out. And by the way, writing stuff out causes you problems. Number 1, you guys like to round or truncate, and you don't do a good job of either one. Number 2, when you write stuff down, you may write it down wrong. Number 3, when you put it back in your calculator, you may enter it wrong. Keep as much stuff in your calculator as you can to avoid that kind of stuff. Okay, so now we need to do the final one, and it's 4 negative minus 11 equals negative 15. What do I do next? Square it, and then what do I multiply by? 0.1. And what do I do with that number? Store 3, right? Now what do I do? Yeah, you add them all up. Recall 1 plus recall 2 plus recall 3 equal. Is that the standard deviation? No, what is that? It's the variance. How do we get standard deviation? Got to take the square root. I'm getting 5.74, this one right here. Is that right?
Yes.
Cool. Okay. If you get the expected return wrong, what happens to the rest of the problem? Yeah, everything just goes to hell, right? Number 15. A 7.5% coupon bond with 9 years left to maturity is priced to offer an 11.2% yield to maturity. You believe that in 1 year the yield to maturity will be 8%. What is the change in price the bond will experience in dollars? Okay, well, if the yield to maturity is dropping from 11.2 down to 8, what do we expect to happen to the bond price? It's going to go up, right? Because yield to maturity and bond prices move in opposite directions. The most common reason students miss this problem is because they miss that line in 1 year. They missed the line in 1 year, and we're going to see where that comes into play. So get your calculator up here. We're going to figure out the price of the bond to start with. So second, clear TVM. What do I put in for face value? 1,000. Oh, by the way, they also tell us it's semi-annual coupons. If it's got 7.5% coupons, how much does that mean each coupon is? 75 per year. Divided by 2 is 37.50, I believe. Okay, 37.5 payment. And we've got 9 years left to maturity. What do I put in for N? 18. And then what do I put in for I per Y? Yeah, 11.2 divided by 2. So let's just do 11.2 divided by 2 equal I per Y. And then to get the bond price, what do I do? Yeah, compute the present value. So there it is, and I'm going to hit negative here and say store 1. And the reason I do that is because we're going to be subtracting this from the next one to figure out what the change is. So I'm going to hold on to that thing. Okay, now, there are 2 things that change for the coming year. What are they? Yeah, the number of periods left. So we had 18. Now what do we got? 16. So we're going to say 16. And what's the other thing that changed? Yeah, I over y. And it's going to be 8 divided by 2, or 4 I per y. How do I get the bond price? Compute present value. So there is my new bond price. I'm going to kill off that negative sign there and then subtract, recall, 1. And that tells me that that bond has changed value of $177.34. Is that the correct answer? Very good. Okay, number 16. A 5.75% coupon bond with 12 years to maturity is offered for sale at $828.47. What yield to maturity is the bond offering? So I'm going to say second, clear TVM. I'm going to put in 1,000 for the future value. They tell us that it's semi-annual. 12 years left to maturity. What's N? 24. 24 N. And it's offered for sale at $828.47. $828.47. What do I need to do with that number? Negative. And then what do I hit? PV, right? Present value. 5.75% coupon bond. How much does this pay annually in coupon? 57.50. And then the semi-annual is how much? Yeah, 20. So I'll just do that so you guys can see the math that he did in his head. Divide by 2 equals 28.75. I'm going to put that in for PMT. I think I've already put in 1,000 for the future value. So the only thing that's left is for me to compute I per Y. Now the question is this the yield to maturity? No, why not? You got to multiply it by 2, right? Now, notice the 4% is one of the answers there. I'll bet that just frustrated the living fire out of some of you, right? Whoever asked for this one. It's actually 8%. You got to remember those halves and twos, right? Okay, coupon bond pays interest at $80 annually as a par value of $1,000, matures in 5 years. It's selling today at a 75-25 discount from par value. The current yield of this bond is What is current yield? Yeah, it's the annual coupon divided by the bond price. How much is our annual coupon here?
80.
80. That one's easy. What's our bond price? Yeah, it's 1,000 minus 75.25. So we're going to take 80 divide by open parentheses 1,000 minus 75.25 close parentheses equal. I'm getting 8.65%. Questions? Cool. Ooh, what's the taxable equivalent yield on a municipal bond with a yield to maturity of 4.55% for an investor in the 35% marginal tax bracket? So our normal formula that we've talked about says that the municipal bond has to return the same as the taxable bond multiplied by 1 minus T, which is that marginal tax rate of the investor. In this case, what they're asking us for, this taxable equivalent yield, it's this thing right here, taxable equivalent yield. And so what we've got to do is solve this equation for that. So I sub T is equal to I sub M divided by 1 minus T. Do you guys see that? Okay, now, what is the municipal bond yield? 4.55%. Divide by, 1 minus 0.35. And so I'm going to get my calculator out here. And I'm going to say 4.55 divide by, what's 1 minus 0.35? 0.65, very good. I'm getting 7%, is that the correct answer?
Yes.
Very good. Any questions? That's easy. 19, a client in the 33% marginal tax bracket is comparing a municipal bond that offers a 4% yield to maturity and a similar risk corporate bond that offers 6.25% yield. Which bond will give the client more profit after taxes? Well, in this case, we can just take, we could go either way with this one. All I have to do is convert one to the other, right? And so we've got our how to get it into the municipal. And so we'll look at the taxable bond here. What's the return on the taxable bond? What's the yield on the taxable bond? 6.25%. Multiplied by 1 minus, what's the marginal tax rate? 33%, so 0.33. And so what we got here is, let's go ahead and say 1 minus 0.33. I know it's 0.67, but some of you might not be able to do that in your head. We're going to multiply that by a 6.25 equals. So that's going to come out to be 4.1875%. Which bond would you rather have? Yeah, the corporate bond. In case you have any question at all, always ask yourself, would I rather have more money or less? And your greedy little heart will lead you to the truth. Questions? Number 20. If the nominal interest rate per year is 12% and the inflation rate is 5%, what is the real rate of interest? Here's my guess. Someone chose 7% using the approximation and got it wrong.
It's for the bars.
It's what?
It's for the bars.
It's for bars, yeah. It's only for cocktail napkin conversations, right? When you're talking about real money, which of course we are, then you're going to use the Fisher effect. What is the Fisher effect? 1 plus big R is equal to 1 plus little r times 1 plus h. What's h?
Inflation.
Inflation. What's little r? Real return. What's big R? Nominal. And so they're asking us what's the real rate of interest. I'm going to rearrange this. 1 plus big R over 1 plus h is equal to 1 plus r. Did I break any laws there? No. Okay, so here's what I'm going to do. I'm going to say 1.12 divided by 1.05 equal, and then what do I have to do? Minus 1. And that tells me that it's actually 6.67. Questions? Always use the Fisher effect. Transportation stocks currently provide an expected rate of return of 12%. TTT, a large transportation company, will pay a year-end dividend of $1 per share. If the stock is selling at $60 per share, what must the market's expectation of the constant growth rate of TTT dividends be? Okay, here we go. I'm going to write a formula up here. The return is equal to the dividend yield plus G. You guys remember that? Okay, in this situation, they've given us this, this, and this, and they're asking for this. So we're going to rearrange the formula. I'm going to say G is equal to R minus D1 over P0. Have I blown anybody's mind yet? Okay, now, what is R? Yeah, 12%. Or in this case, I'm going to say 0.12 because we're going to do this ratio here. Minus, what's the dividend at time 1? 3. And how much is the stock price?
60.
60? 3 over 60 is 1 over 20, which is 0.05. Or you can put it in your calculator and get 0.05. So what's 0.12 minus 0.05? 7%, isn't it? Is that the correct answer? There you go. Universal Vacuum is a no-growth firm. Why? Because it sucks. Sorry, that just came to me. Yeah. Oh, that was some lame little stuff. Has 4 million shares outstanding and expects to earn a constant $20 million per year on its assets. It has no debt. All earnings are paid out as dividends. The cost of capital is 10%. Calculate the current price for the share of stock. Okay, if this thing is not growing, the growth rate is 0. What does that mean for the dividend year after year after year? It's got to be the same, right? And we can look at this right now and see that this thing is paying $20 million divided by 4 million shares. How much is the dividend this thing is paying? $5 per share, because 20 divided by 4 is 5. By the way, the millions cancel out, so I don't even have to worry about those. Now, I got $5 per share. The cost of capital is 10%. How can I figure out the value of this stock? Yeah, it's just P sub 0 is D over R, so it's just 5 divided by 0.10. So I think this thing should be selling at $50. Is that correct? Mm-hmm. 23, a firm does not pay a dividend. It is expected to pay its first dividend of 54 cents per share in 3 years. The dividend will grow at 9% indefinitely. Using a 10% discount rate, compute the value of this stock. I'm going to walk through this and I'm going to explain it in detail, and I guarantee 3 of you will still make the same mistake on the exam. But we're going to walk through it and hopefully we can save some of you from doing it. Okay, first of all, the dividend that they give us. What dividend is that?
0.
Ooh.
A firm does not pay a dividend.
A firm does not pay a dividend. It's expected to pay its first dividend in 3 years. So 54 cents is D3. That's the first thing to make note of. Now, we have to figure out, by the way, I can figure out a stock price that represents that D3 and then the growth that goes after that. The problem is people forget which price it is that they're calculating. If I use D3 to calculate, I'm going to end up with P2. P2 is equal to D3 divided by R minus G. Does that look right? Remember, this is always one behind that. Okay, now I've got 0.54 here. Divide by R minus G. R is 0.10, growth is 0.09. And so I think we're looking at $54. Does that sound right?
Yes.
Okay, we're so close. That is $54 hanging out there in the future. How do I bring that back to time 0 to figure out what is the stock price today? I'm going to treat that 54 as a future value. Now, let's go to our calculator here. Say second clear TBM. I'm going to put in that 54 for future value. What do I put in for I per Y? 10. I per Y. What do I put in for N? 2. Most common mistake. What do people put in? 3. And then I'm going to compute what? PV. We're getting $44.63. Is that correct?
Yes.
All right. Oh yeah, this one messes people up. A firm has been losing sales due to technological obsolescence. By the way, if it's losing sales, is G positive or negative? Negative. It projects growth rate for the future to be minus 7%. So let's go ahead and write this down. G is equal to minus 0.07. Its recent dividend was $2. Is that D0 or D1? D0. Remember, past or present is D0. Future, no more than 1 year, is D1. So that's going to be D0. D0 is equal to $2. And they say the required return is 0.09, is 9%, so 0.09. So our normal formula says P sub 0 is equal to D1 over R minus G. But do we have D1? No. What do we have? D0. So I've got to do a little substitution here. D0 multiplied by what? 1?
Minus
1 plus G, right? Because it's growing by the growth rate. Now, the growth rate is negative here. That's probably what you're thinking. Okay, so this, now we are finally down to where we can calculate things. So I'm going to take 2 multiplied by 1, and that plus G is minus 0.07, divide by, and this is where people really screw up. What do people usually do? They usually take 0.09 minus 0.07. Is that correct? No, it's 0.09 minus 0.07. And so that's actually a plus. So I think if we do the math out here, we get what, $1.86 divide by 0.16? Is that right? Okay. $1.86 divide by 0.16, and we get $11.63. A conceptual question you can ask students, and they'll usually get wrong, is would you be willing to buy stock in a company who has negative growth? Yeah, it's worth $11.63, right? That's what those future cash flows are worth. Okay. Ooh, we're getting close. I'm getting excited. Number 25. In tech, just pay the dividend of $2 per share. Is that, I'm going to ask Mr. Menace, is that D1 or D0?
Which one else? Just paid? Oh, that's
D0.
Oh, yeah, my bad.
Dude, twice in a row. Okay, I'm going to give you a chance to reclaim your dignity here.
Thank you.
Is that D1 or D0?
Oh, D0.
Very good.
I thought you were asking a new question.
No. We've got a low bar for reclaiming dignity in this class. D0 is equal to $2 a share. Analysts expect his dividend to grow at 25% for the next 3 years. And then at 5% per year thereafter. If the required return on the stock is 18%, what is the current value of the stock? When you are faced with such a problem, what is your first step? Draw a picture. Okay, so we know, it says just paid, we know that's D0. And then, so I'm going to go ahead and draw some lines here. 1, 2, 3, 4, 5, 6, 7, 8. I don't know how many have to go out. Yeah, that's fine. Okay, so just paid, and then they tell us for the next 3 years. How do I figure out when that 3 years is up? The kindergarten method. In fact, I will get the red pen out just to make this extraordinarily clear. Here we go. 1, 2, 3. Now, let's talk about what years those are. 1, 2. I screwed something up? So it's going to grow for 3 years. 1, 2, 3. Hopefully I have this straight again.
Do you start counting from 0 or from 1?
Ah, good question. Why did I start from 0? Because that's the dividend they gave me, right? If I gave you D1 and then said it grew at a percentage rate for the next 7 years, you would start with D1 and you'd go 7 over. That's an excellent question. So you've got to read. That's why the first thing, and I asked Mr. Menace, and he told us very correctly that it was D0. That it was D0 because we know for two things. Number one, we've got to know where that is in order to be able to get our dividends right. Number two, we have to know so we know how many years of that first rate of growth that we have. Okay, now what does that mean we're going to be calculating for this thing? Well, we've got D1, D2, D3. Do we collect D0? No, we never collect D0 unless I tell you to, and I will never tell you that. So there we go. So 1 through 3, and then there's one more thing that we have to calculate. P3, right? So we're going to have to figure out a price here that represents all those dividends going forward. Now, P3 is equal to D4 divided by R minus G2, that second growth rate. But we don't know, we won't know D4. What will we know? D3. And so it's going to be D3 multiplied by 1 plus G2 divided by R minus G2. And so we're going to have to do that when we get there. Now, what am I going to have in my calculator when this is all said and done? How much is C of 0 going to be? 0. C01 is going to be equal to D1. C02 is going to be equal to D2. C03 is going to be equal to
D3 plus
G3 plus P. P3. Okay, now let's get started. Let's get the calculator out, and we're going to clear it. We're going to say CF, second, clear work. CF0 is 0, I skip down to C01. How do I figure out what C01 is? It's 2 times 1.25, because that's the first growth rate, right? So I'm going to say 2 times 1.25 equals, I'm going to do two things here. I'm going to hit enter, and I'm also going to hit store 1. Arrow down, arrow down. What's the first thing I do here? Recall 1 multiplied by 1 plus that first growth rate equals, I'm going to enter, and what am I going to do with that number? Store 2. Then I'm going to arrow down, arrow down. What do I do here?
Recall 2.
Recall 2 times that first growth rate of 1.25 equals, enter, store 3. Now, in order to get from here to P3, we've got to multiply this by 1 plus the second growth rate, divide by R minus the second growth rate. So here we go. We're going to multiply by 1.05 equal. And then we're going to divide by, what is 0.18 minus 0.05? 0.13. Oh my goodness, guys. You keep your calculators close and your friends closer, right? Phew. I'm getting 3155 as P3, is that right?
Yes.
Okay, now, is that the only thing that goes into C03? No, what am I going to do now? Add D3, which we have stored in location 3. And there we go. Now I hit enter. If I don't hit enter, it's like it never even happened. How am I going to get the present value of these dividends now? NPV. And what should I put in for I? 18. Enter. Arrow down. Compute. I'm getting $25.94. Is that the correct answer? Okay, let's talk about the things you need to read for. You need to read to find out whether it's D0 or D1. You need to read to find out whether it's covariance or correlation. You need to read to find out whether it's market premium or expected return on the market. Those are the 3 biggest skipped over things that will mess people up. And by the way, do you think I am cruel enough to include those if you use it the other way as one of the possible choices? Absolutely I am. Absolutely I am. By the way, life is hard, life is cruel, and then we die. And I'm just giving you a little taste of all that right here with my close mistake answers. Questions? Is there anything else we can talk about that will help you to do better on exam 2? Yes?
Can you go over the standard deviation, like the deviation chart again?
So how to do it
Like, yeah,
by hand?
or just like I got lost kind of. in the
Oh, okay.
chart.
Yeah.
I don't remember what number it was, it goes towards the beginning.
Yeah. Well, undoubtedly, if you got lost, other people did too. 14.
I think so.
Yeah, this one's popular. I've already had people come to my office about it. Okay, here we go. First thing we want to do is read what they're asking. They're asking for the standard deviation. There are 2 ways we end up getting standard deviation. There's the easy way, where we could put it in the calculator, but we're going to have to read to see if this is one of those. And as soon as we say your investment has a 40% chance, you know automatically it's not one of those. So you're going to have to start making your table. And the first column is going to be your probabilities. We have a probability of 40% for the first case. We have a probability of 50% for the second case. And we have a probability of 10% for the third case. Then we need to look at what the returns are in each of those cases. What is the return in the first case? 16%. By the way, I could have turned these into decimals, or I could leave them as percentages. Turning stuff into decimals always works as long as you remember. Leaving stuff as percents works sometimes. So if you're unsure, if your math isn't that great, I would tell you to go with the decimals. Okay, so 16% in the first case. What's the second case? 10%. And in the third case, negative 4%. Okay, now what is the very next thing that we need to calculate? Yeah, the expected return. And the expected return is going to be equal to 0.4 times 16% plus 0.5 times 10% minus 0.10 times 4%. Have I blown your mind yet? Okay. So I'm going to go through and do these. You can do them in your calculator. But here they go. And you could save them as 1, 2, and 3, and then add them together if you're having trouble, with your order of operations. But this one is 6.4%. This one is 5%. And this one is minus 0.4%. Okay. Now, when I add 6.4% to 5% to get 11.4%, 11.4% minus 0.4% gives me how much? 11%. Okay, so the next column here, which I'm going to call deviation, we could say is R minus the expected return. And so what is 16 minus 11? 5%, right? What is 10 minus 11? Minus 1%. And what is minus 4 minus 11?
Shouldn't it be less when since it's minus 0.04?
No, because I moved, so this is actually minus, so I should have the negative sign out. Are we in agreement that it's 11? Okay. Okay, so that's minus 15%. Now, in the exam, would I work in this direction? No. So here's what we're going to do. Let's go ahead and do this in our calculator so we'll have it, so you'll see how it works. We're going to take 16 minus 11. That's going to give us the deviation. And then the next thing we're going to figure out is the deviation squared. How would I get deviation squared here? I just hit the square button, right? That's going to be 25. And then I'm going to multiply that times the probability. What's the probability of this situation? 0.4, right? Multiplied by 0.4 equals, I'm getting 10. Now, I'm going to store that in location 1. Okay, now the next one, I'm going to take 10 minus 11, that gives me that deviation of negative 1. What's the next thing that I do? Square it, and that gives me positive 1. And then I'm going to multiply that times the probability. What's the probability? 0.5 equal. And I'm going to store that in location 2. Okay, on the last one here, minus, let's see, so we're going to say 4 minus, subtract 11. That gives me negative 15. What's the next thing that I do? Square it. And then we're going to multiply by the probability. What's the probability? 0.1 equal. I'm getting 22.5, and I'm going to store that in location 3. So this was what, 225, and this was 22.5? Is that right? Okay, now, what am I going to do with these three numbers? I'm going to add them together, and what's that going to give me?
The variance.
Variance. So here we go. Recall 1 plus, recall 2 plus, recall 3 equals. I'm getting 33. Now, that's our variance. How do I get to the standard deviations? Square root. Boom, 5.744. Does that help you out?
Yeah, I think I got confused because I started in decimals,
Oh.
and so it was weird when we started getting the effective return and everything.
Yeah.
That-
Okay, so if you're going to do decimals, do everything in decimals. And like I said, so I've been doing this a while. You guys know Dr. Whitty? Yeah. So he was one of my professors at Mizzou, and I was doing a calculation one time, and I'm like, yeah, Doug, I can figure this out. And he says, that's because you use percent here and decimals here, dumbass. And so I've gotten better over the years, so has he. I've gotten better over the years at figuring these things out. So I naturally know when I can and can't. You may not. You may not. So what I tell you is convert all your percentages into decimals and just remember to convert back when you're done. And then you'll be okay. Other questions? Okay. Good luck. Have a great spring break. I hope you come back with both eyes.